Section 2.4 Multiplication and Division of Integers. In this video, we will learn about integer properties of multiplication, the product of two integers with different signs, the product of two integers with the same sign, the distributive property with integers, the multiplicative property of 0, multiplying by -1, a memory device, and division of integers. Before we begin, let it be known that the integers satisfy the same properties of multiplication as do the whole numbers. And so the following we have the integer properties of multiplication. Integers satisfy the commutative property, where if a and b are integers then their product commutes, that is, a times b equals b times a. Integers satisfy the associative property. If a and b and c are integers, then their product is associative, that is, whether we group a and b or b and c, the two expressions are equal. Integers satisfy the multiplicative identity property. If a is any integer, then a times 1 equals a, and 1 times a equals a. Because multiplying any integer by 1 returns the identical integer, the integer 1 is called the multiplicative identity. In section 1.3, we learn that multiplication is equivalent to repeated addition. For example, 3 times 4 was equal to 4 plus 4 plus 4, 3 4s added together. On the number line, 3 sets of 4 is equivalent to walking 3 sets of 4 units to the right, starting from 0, as shown in figure 2.14. This example and a little thought should convince readers that the product of two positive integers will always be a positive integer. So we have the product of two positive integers. If a and b are two positive integers, then their product, a times b, is also a positive integer. For example, 2 times 3, where 2 and 3 are positive, equals positive 6. And positive 13 times positive 117 equals a positive 1,521. In each case, the product of two positive integers is a positive integer. But what about the product of a positive integer and a negative integer? So, two integers of different signs. If we continue with the idea that multiplication is equivalent to repeated addition, then it must be that 3 times a negative 4 equals a negative 4 plus a negative 4 plus a negative 4. So the sum of 3 negative 4s. Pictured on the number line, positive 3 times negative 4 would then be equivalent to walking 3 sets of negative 4 units to the left starting from 0, as shown in figure 2.15. Note, at least in this particular case, that the product of a positive integer and a negative integer is a negative integer. We have shown that 3 times negative 4 equals negative 12. However, integer multiplication is commutative, so it must also be true that negative 4 times 3 equals negative 12. That is, the product of a negative integer and a positive integer is also a negative integer. Although not a proof, this argument motivates the following fact about integer multiplication. The product of a positive integer and a negative integer. Two facts are true. 1. If a is a positive integer and b is a negative integer, then the product, a times b, is a negative integer. 2. If a is a negative integer and b is a positive integer, then the product, a times b, is also a negative integer. Thus, for example, 5 times negative 12 equals negative 60, and negative 13 times positive 2 equals negative 26. In each case, the answer is negative because we are taking a product where one of the factors is positive and the other is negative. The distributive property. The integers satisfy the distributive property as well. If we let a, b, and c be integers, a times the sum of b and c equals the product of a and b plus the product of a and c. We say that multiplication is distributive with respect to addition. Note how the a is distributed. The a is multiplied times each term in the parentheses. For example, consider the expression 3 times the sum of 4 and 5. We can evaluate this expression according to the order of operations. Simplify the expression inside the parentheses first. 4 plus 5 is 9, then 3 times 9 is 27. But we can also use the distributive property, multiplying each term inside the parentheses by 3, then simplifying the result. So, 3 times the sum of 4 and 5 is equal to the product of 3 and 4 plus the product of 3 and 5 when we distribute the 3. Then, the product of 3 and 4 is 12, and the product of 3 and 5 is 15. Then, the sum of 12 and 15 is 27. Note that evaluating 3 times the sum of 4 plus 5 using the distributive property provides the same result as the evaluation 2.1 using the order of operations. The multiplicative property of 0. The distributive property can be used to provide proofs of a number of important properties of integers. One important property is the fact that if you multiply an integer by 0, the product is 0. Here's a proof of that fact that uses the distributive property. Let a be any integer, then a times 0 equals a times the sum of 0 and 0, and distributing the a, we get the product of a and 0 plus the product of a and 0. Next, to undo the effect of adding the product of a and 0, subtract the product of a and 0 from both sides of the equation. We have on the left side the product of a and 0 minus the product of a and 0, which is 0, and on the right side just one product of a and 0 left. So 0 equals a times 0. So the multiplicative property of 0. Let a represent an integer, then a times 0 equals 0, and 0 times a equals 0. Thus, for example, negative 18 times 0 equals 0, and 0 times 122 equals 0. Multiply by minus 1. Here's another useful application of the distributive property. We have negative 1 times a plus a. Replace a with 1a. Then we get negative 1 times a plus 1a. Use the distributive property to factor out a. So the sum of negative 1 and 1 times a. Replace negative 1 plus 1 with 0. Then we get 0 times a, and 0 times a is 0. Thus, negative 1 times a plus a equals 0. However, the additive inverse property says that negative a is the unique number that you add to a to get 0. The conclusion must be that negative 1 times a equals negative a. Multiplying by minus 1, if a is an integer, then a negative 1 times that integer equals the negative integer. Thus, for example, negative 1 times 4 equals negative 4, and negative 1 times negative 4 equals negative times negative 4 equals 4. This property is rather important, as we will see in future work. Not only does it tell us that negative 1 times a equals negative a, but it also tells us that if we see negative a, then it can be interpreted to mean a negative 1 times a. The product of two negative integers. We can employ the multiplicative property of negative 1, that is, negative 1 times a equals negative a, to find the product of two negative integers. Negative 4 times negative 3 equals a negative 1 times 4 times negative 3. So we replace negative 4 with negative 1 times 4. Then use the associative property to regroup the numbers, grouping 4 and negative 3. Then simplify within the brackets to get negative 1 times negative 12, since 4 times negative 3 is negative 12. Then replace negative 1 times negative 12 with negative times negative 12. Then negative times a negative would make it a positive 12. Thus, at least in the case of negative 4 times negative 3, the product of two negative integers is a positive integer. This is actually true in general. The product of two negative integers. If both a and b are negative integers, then their product, a times b, is a positive integer. Thus, for example, negative 5 times negative 7 equals 35, and negative 112 times negative 6 equals 672. In each case, the answer is positive, because the product of two negative integers is a positive integer. Memory device. Here's a simple memory device to help remember the rules for finding the product of two integers. Like and unlike signs. There are two cases. Unlike signs. The product of two integers with unlike signs is negative. That is, a positive times a negative is negative, and a negative times a positive is negative. Like signs. The product of two integers with like signs is positive. That is, a positive times a positive is a positive, and a negative times a negative equals a positive. Example 1. Simplify a negative 3 times negative 2. So, like signs gives a positive result. Hence, negative 3 times negative 2 would be positive 6. B, positive 4 times negative 10. Unlike signs gives a negative result. Hence, positive 4 times negative 10 is negative 40. C, positive 12 times negative 3. Unlike signs again, give a negative result. Hence, positive 12 times negative 3 would be a negative 36. Example 2. Simplify negative 3 times 2 times negative 4 times negative 2. Solution. Order of operations demands that we work from left to right. Working left to right, negative 3 times positive 2 equals a negative 6 since we have unlike signs. Then a negative 6 times negative 4 equals a positive 24 since they're both negative. Then 24 times negative 2 equals a negative 48, negative because they are unlike signs. So the result is negative 48. Example 3. Simplify. A is negative 2 cubed and C negative 3 to the 4th power. Solution. In each example, use a to the m equals a times a times a and so on m times. Then work left to right with the multiplication. So with a, use the definition of an exponent, then order of operations. We have negative 2 raised to the 3rd power, so there's 3 factors of negative 2 multiplied together. Working from left to right, negative 2 times negative 2 is a positive 4 since we have like sign integers. Then a positive 4 times a negative 2 would be a negative 8 because we have unlike sign integers. B, use the definition of an exponent, then order of operations. We have negative 3 raised to the 4th power, so according to the definition of exponents, there are 4 factors of negative 3, since the exponent is 4. So working from left to right, the first 2 factors, negative 3 times negative 3, would be a positive 9 since they have the same sign. Then 9 times negative 3 would be a negative 27 since we have a positive and negative integer. Then now we have a negative 27 and negative 3, which would make a positive 81 since they're both negative. So the result is positive 81. Even and odd. 2 facts are apparent. If a product contains an odd number of negative factors, then the product is negative. 2. If a product contains an even number of negative factors, then the product is positive. So let's look at example 3 again. Notice that with A, there are an odd number of factors with the exponent 3, and the result was negative. Notice with B, there are an even number of factors with an exponent of 4, and the result was positive. So even and odd number of factors, the result is negative. Even number of factors, the result is positive. Thus, for some additional examples, with negative 2 raised to the 5th power, there are 5 factors of negative 2, an odd number of factors, so the result would be the 2 multiplied by itself 5 times, and then negative because there's an odd number of factors. The next example, we have 6 factors of negative 2. Multiply 2 6 times to get 64, and then we know that the result has to be positive because we have an even number of factors. So these are just some quick ways to evaluate exponent expressions. Division of integers. Consider that 12 divided by 3 equals 4 because 3 times 4 equals 12, and negative 12 divided by negative 3 equals 4 because negative 3 times 4 equals negative 12. In like manner, 12 divided by negative 3 equals negative 4 because negative 3 times negative 4 equals 12, and negative 12 divided by 3 equals negative 4 because 3 times negative 4 equals negative 12. Thus, the rules for dividing integers are the same as the rules for multiplying integers. Like and unlike signs. There are 2 cases. Unlike signs. The quotient of 2 integers with unlike signs is negative. That is, a positive divided by a negative is a negative, and a negative divided by positive is negative. Like signs. The quotient of 2 integers with like signs is positive. That is, a positive divided by a positive is positive, and a negative divided by a negative is positive. Thus, for example, 12 divided by a negative 6 equals a negative 2 since we have unlike signs, and a negative 44 divided by a negative 4 would be a positive 11 since we have like signs. One final reminder. Division by 0 is undefined. If a is any integer, the quotient a divided by 0 is undefined. Division by 0 is meaningless. For a more detailed discussion, see section 1.3. Example 4. Simplify. A, negative 12 divided by a negative 4. Like signs gives a positive result, hence negative 12 divided by negative 4 is a positive 3. B, C divided by negative 3. Unlike signs gives a negative result, hence positive 6 divided by negative 3 equals a negative 2. C, negative 15 divided by 0. Division by 0 is undefined, hence negative 15 divided by 0 is undefined.